Magandang araw, isang mapagpalang araw sa ating lahat, my dear students. In this video, we will discuss about dilution. So at the end of this video, you must be able to define what dilution is, describe the dilution process, and solve problems on dilution. So dilution refers to the process of adding additional solvent to a solution to decrease its concentration. Now take note that the process keeps the amount of solute constant, but the increase in the amount of solvent causes an increase in the total amount of solution and thereby decreasing the final concentration, though the amount of solute is constant, as I said earlier. So I have here a diagram. So suppose this is the original solution. So, kunwari, yung mga dots na yan yung ating solutes, no? So, kunwari, meron tayong 2, 4, 6 moles of solute. Then, after dilution, we add additional solvent. So, kunwari, na-double yung amount ng solution. Ano? But take note that we still have the same amount of solute. So, 2, 4, 6 pa din. So this is before dilution and this is after dilution. Observe that the molarity of the first solution is equal to the number of moles of the solute in the first solution divided by the volume of the solution in liter. Similarly, the molarity of solution 2 is equal to the number of moles of solute in solution 2, which is the solution after dilution, divided by the volume of the solution in liter. Note that, as I mentioned earlier, the number of solutes of the number of moles rather of the solute remains the same, such that the number of moles of the first solution is equal to the number of moles of the second solution, such that molarity times volume in liters of the first solution is equal to the molarity of the second solution times the volume in liter of the second solution. If we let molarity be C and the liter be V, then we have C1V1 is equal to C2V2, where C1V1 refers to concentration and volume of solution 1 and C2V2 the concentration and volume of solution 2. Now, in some books, instead of C1V1, they have M1V1 to emphasize that the concentration is in terms of molarity. Now, when calculating dilution factors, it is important that the units for both volume and concentration are the same for both sides of the equation. So, let's have some problems. Okay. So we have 175 ml. No? Hindi ko na ginawang salita, pero alam natin sa English dapat hindi figure, no? Dapat word ito. Yung if we observe correct grammar. So 175 ml of a 1.6 molar aqueous solution of lithium chloride is diluted with water to a final volume of 1.0 liter. Or 1000 ml, no? From 175 ml to 1000 ml. What is the final concentration of the diluted solution? So we are given the initial concentration, 1.6 molar, the initial volume, 175 ml, final volume, which is 1 liter or 1000 ml. And we are required to find the final concentration. So using C1V1 equals C2V2, looking for C2 or the final concentration, we have C1V1 over V2, and then substituting the values, 1.6 molar times 175 ml divided by 1000 ml is equal to 0.28 molar. Okay, so nakita nyo yung pagbaba ng concentration, no? From 1.6 naging 0.28 kasi dinagdagan natin ng solvent. Okay. Another example, nitric acid, or if this should have been HNO3, this should have been subscript. HNO3 is a powerful and corrosive acid. When ordered from a chemical supply company, its molarity is 16 molar. How much of the stock solution of nitric acid needs to be used to make 8.0 liters of a 0.5 molar solution? So abstracting the data from the problem, C1 is equal to 16 molar V2 is equal to 8 liters. C2 is 0.5 molar. We are required to find the initial volume. So using C1V1, we have C2V2. Solving for V1, we have C2V2 over C1. Okay, this should have been C1. So correction, C1 ito. No? So we have 0.5 molar times 8 liters over 16 molar. That is 0.25 liter or 250 milliliters. So how do we interpret this? No? We need to measure 250 ml of the original solution, which is the concentrated nitric acid, and dilute it to 8,000 ml to get the desired concentration of 0.5 molar. Okay. So we have here a diagram of a serial dilutions, no, which involve diluting a stock or standard solution multiple times in a row. No? Sa laboratory kasi, ang practice, nagpe-prepare ka na ng stock or standard solution, yung known, yung concentration. So, you measure a known amount of solute and then dissolve that in known amount of solvent to get the desired concentration. Okay? And from there, kukuha ka na lang ng part ng aliquot. Tapos, i-dilute mo. Okay? So normally, ganyan ang nangyari. May factor, may dilution factor yun, which remains constant for each dilution, resulting in an exponential decrease in concentration. So here, we have 1:10, 1:100, 1:1000, 10,000, and 100,000. Notice also the decrease in the color. No? So from here, more concentrated until this part. So, mas diluted, no, yung pakanan. Okay, so for example, a 10-fold serial dilution could result in the following concentrations: 1 molar, 0.1 molar, 0.01, 0.001, and so on. So, makikita natin yung powers of 10, no? Now, serial dilutions are used to accurately create extremely diluted solutions, as well as solutions for experiments that require a concentration curve now with an exponential or logarithmic scale. Now, these serial dilutions are widely used in experimental sciences, including biochemistry, pharmacology, microbiology, and physics. Okay? So here are some exercises, no, involving dilution. I hope you will find time to solve this, no, so that you will be more adept, no, in solving problems involving dilution. So you just use C1V1 is equal to C2V2. So that's all for now. Thank you for listening, and I'll see you next time. In the meantime, you practice self-love and self-care. See you when I see you, class. Bye for now.